Have you ever wondered what makes a robot move? How can a robot move forward, turn, spin, or stop? And what about a drone? How can it fly, change direction, rotate in place, and even stay in one position in the air? Is it simply because of the motors? Well, not exactly. Robotic motion is actually the result of several components working together as one system. Welcome to our lesson, Components of Robotic Motion and Drone Technology.
Welcome to my channel, Science with a Touch of Hugot. Let's explore! Discover short stories and discover ourselves.
Robots are designed to move, interact with their surroundings, and perform tasks with accuracy and efficiency. Whether a robot moves forward, turns, spins, hovers, or flies, its movement depends on several components working together. A drone is a great example. A drone can take off, move forward or backward, turn, rotate, hover in one place, and land. But how does it know what to do? What makes its motors spin? And how does it maintain balance while flying? In this lesson, we will explore the components of robotic motion and discover how these components are applied in drone technology. By the end of this lesson, you should be able to 1. Identify the major components responsible for robotic motion. 2. Explain the functions of motors, actuators, controllers, sensors, power supplies, and mechanical parts. 3. Describe how these components work together to produce different types of motion. 4. Identify the major components of a drone and explain their functions. 5. Explain how drones achieve forward, backward, turning, rotation, hovering, and flight. 6. Analyze simple situations involving robotic motion and drone movement. Are you ready? Let's get started. What makes it move? Imagine you are watching a drone flying above you. It suddenly moves forward. Then, it moves backward. It turns left. It rotates in place. Finally, it stops and hovers in the air. Question: what makes all these movements possible? Is it only the motor? Or are there other components working together? Quick challenge. Look at each situation and think about what the robot or drone might need. Situation 1. A robot moves forward. What component or components might help? Situation 2. A robot detects an obstacle. What does it need to detect that obstacle? Situation 3. A drone changes direction. What might control that movement? Situation 4. A drone remains stable while hovering. What helps it maintain its balance? Situation 5. A drone's motors continue spinning during flight. Where does the energy come from? Can one component make a robot move by itself? The answer? Robotic movement is a team effort. And now, let's discover why. Components of robotic motion. Robotic motion does not happen because of only one component. It is the result of several components working as a system. Here is a simple way to remember the process. Sense, think, act, move. The robot senses its environment. The controller thinks or processes the information. The actuators act by producing physical movement, and the mechanical parts help create the actual movement. Let's examine each component. 1. Power supply. The power supply provides the electrical energy needed by the robot. Examples include batteries, rechargeable battery packs, power adapters, and solar power systems. Without sufficient power, the robot's motors, sensors, and controller cannot operate properly. Imagine trying to run a robot without energy. Nothing happens. It is like trying to use your phone with a completely dead battery. No power, no action. Quick check. What is the main purpose of a robot's power supply? A. To detect obstacles. B. To provide electrical energy. C. To change the robot's direction. D. To hold the robot's wheels. The correct answer is B. To provide electrical energy. 2. Controller. The controller acts like the robot's brain. It receives information from sensors and determines what the robot should do. Examples include microcontrollers, programmable controllers, robot control boards, and flight controllers in drones. For example, a sensor detects an obstacle. The controller processes the information. Then the controller commands the motor. The robot changes direction. So we have sensor, controller, motor, movement. Think about it. If a robot detects an obstacle and then decides to turn, which component processes the information and tells the robot what to do? The answer is the controller. 3. Sensors. Sensors allow robots to gather information from their surroundings. Some common sensors include ultrasonic sensors, infrared sensors, light sensors, cameras, gyroscopes, accelerometers, and GPS. Sensors can help a robot determine distance, position, speed, orientation, movement, and environmental conditions. Think of sensors as the robot's way of gathering information about the world around it. Quick check. Complete the sentence. Sensors allow robots to blank information from their environment. The answer is collect or detect. 4. Motors and actuators. Actuators are components that convert energy into physical action. Motors are one of the most common actuators in robotics. They can make wheels rotate, arms move, joints bend, propellers spin, and mechanisms open and close. For example, a wheeled robot uses motors to rotate its wheels. And a drone? A drone uses motors to rotate its propellers. Quick check. A robot needs to rotate its wheel to move forward. Which component is primarily responsible for producing this movement? A. Sensor. B. Motor. C. Battery case. D. Camera. The answer is B. Motor. 5. Mechanical components. Mechanical components transfer and control the movement produced by actuators. Examples include wheels, gears, shafts, belts, arms, joints, propellers, and frames. Here's a simple example. A motor rotates a shaft. The shaft turns a wheel. The wheel pushes against the ground, and the robot moves. Motor, shaft, wheel, movement. Quick check. Which of the following is a mechanical component? A. Gear. B. Sensor. C. Microcontroller. D. Battery. The answer is A. Gear. 6. Communication system. Some robots need to communicate with another device or another robot. Communication systems allow robots to receive commands or send information. Examples include Bluetooth, Wi-Fi, radio communication, and cellular communication. For drones, communication systems can connect the drone to a remote controller. The operator can send commands such as up, down, forward, backward, left, right. The drone receives those commands and responds. Quick check. A pilot uses a remote controller to tell a drone to move forward. What allows the command to travel from the controller to the drone? The answer is the communication system. Putting the components together. Imagine a simple mobile robot. The process may look like this. Battery provides electrical energy. Controller processes instructions. Sensors provide information. Controller makes decisions. Motor actuator produces movement. Mechanical parts transfer movement. Robot moves. See? No single component does everything. It is a team effort. Drone technology. Now let's apply what we've learned to drones. A drone, also called an unmanned aerial vehicle, or UAV, is an aircraft that can operate without a human pilot physically inside it. Many small drones use multiple electric motors and propellers to control their movement. A typical quadcopter has 4 motors and 4 propellers. These components work together to produce controlled flight. But what exactly makes that possible? Let's take a closer look. Major components of a drone. The major components of a drone include the frame, motors, propellers, flight controller, sensors, battery, and communication system. Let's examine the most important ones. 1. Frame. The frame is the structure that holds the drone's components together. It supports the motors, propellers, battery, flight controller, sensors, and communication components. Without a strong and properly designed frame, the drone's components would have nowhere to be mounted. 2. Motors. Drone motors rotate the propellers. By increasing or decreasing motor speed, the drone can change the forces acting on it. This allows the drone to rise, descend, move forward, move backward, move sideways, and rotate. So motor speed is extremely important in controlling drone movement. 3. Propellers. Propellers generate the forces needed for flight. When motors spin the propellers push air and generate thrust. More thrust, the drone can rise. Less thrust, the drone can descend. By adjusting the direction and speed of individual motors, the drone can also control its movement. 4. Flight controller. One of the most important electronic components of a drone is the flight controller. Think of it as the drone's brain. It receives information from sensors and uses that information to adjust the motors. It helps maintain stability, direction, orientation, altitude, and movement. And here's something important. The flight controller doesn't make just one adjustment. It constantly makes adjustments while the drone is flying. It continuously monitors what is happening and changes motor speeds when necessary. Quick check. Why is the flight controller important? A. It holds the propellers together. B. It processes sensor information and controls the motors. C. It stores the drone's battery. D. It acts as the drone's frame. The answer is B. It processes sensor information and controls the motors. 5. Drone sensors. Drones use different sensors to understand their movement and position. One important sensor is the gyroscope. It measures rotational movement and helps determine orientation. Next is the accelerometer. It detects changes in acceleration and movement. We also have altitude sensors, which help determine the drone's height above a surface. GPS, which can help determine the drone's location and support navigation. Together, these sensors provide information that helps the flight controller maintain stable flight. 6. Battery. And of course, we need power. Drones require lightweight batteries that can provide enough energy to power their motors and electronics. The battery supplies energy to the flight controller plus sensors plus motors plus communication system. But here's something interesting. A drone's flight time depends partly on its battery capacity, weight, motor efficiency, and how it is operated. So a battery isn't just about how much energy it stores. The entire drone system matters. How does a drone move? Now we've reached the exciting part. How does a drone actually move? A drone's movement is controlled by changing the speed of its motors. Different motor speeds create different forces, and these forces allow the drone to control its movement. Let's look at each type. Forward motion. To move forward, the drone adjusts the speed of its motors so that it tilts forward. The propellers continue producing thrust. Because the drone is tilted, part of that thrust acts in the forward direction. And the result? Drone moves forward. Backward motion. For backward motion, the drone tilts backward. This changes the direction of the resulting thrust and causes the drone to move backward. And the result? Drone moves backward. Turning. What about turning? To change direction, the flight controller adjusts the speeds of different motors. The drone can tilt or rotate depending on the desired movement. And the result? Drone changes direction. Rotation or spinning. A drone can also rotate around its vertical axis. This movement is called yaw. The flight controller changes the relative speeds of the motors so that the drone rotates while maintaining control. And the result? Drone spins. Hovering. Hovering means staying approximately in the same position in the air. To hover, the drone must produce enough upward thrust to balance its weight. The flight controller continuously adjusts motor speeds to maintain stability. And the result? Drone stays in the air. Flight. Flight is produced when the drone generates enough thrust to overcome its weight. But the flight controller doesn't simply turn the motors on and walk away. It constantly monitors the drone and adjusts motor speeds. This makes drone flight a continuous process. Sense, process, adjust, move. And then the process repeats again and again and again. That is how controlled drone flight is achieved. Match the component. Let's see what you've learned. Match each component with its function. 1. Battery. 2. Motor. 3. Sensor. 4. Flight controller. 5. Propeller. Now match them with A. Detects movement or position. B. Provides electrical energy. C. Produces rotational movement. D. Processes information and controls flight. E. Produces thrust. Let's check. 1B, 2C, 3A, 4D, 5E. How many did you get correct? What happened? Situation 1. A drone suddenly detects that it is tilting to one side. Which component receives sensor information and adjusts the motors to help stabilize the drone? The answer is flight controller. Situation 2. A drone's propeller is not spinning because its motor has stopped. What major problem can occur? The drone may lose balance and control. Situation 3. A drone has enough battery power, but it cannot determine its orientation properly. Which type of component should be checked? The answer is the sensors, particularly the gyroscope or IMU system. Conclusion: robotic motion is not produced by a single component. It is created through the cooperation of several systems. Remember, power provides energy, sensors gather information, controller makes decisions, actuators produce action, mechanical parts transfer movement, communication systems allow commands and information to be exchanged. In drones, all these components work together to produce controlled flight. The motors spin the propellers, the sensors monitor the drone's condition, and the flight controller continuously adjusts the motors. So when you see a drone flying, remember, a drone does not simply fly. It senses, thinks, adjusts, and moves. Final Robotics Hugot. Parang robot, hindi sapat ang gustong gumalaw. Kailangan mo rin ng power, direction, at control. Because just like a drone, you need power to keep going. You need direction to know where you're headed. And you need control to stay on the right path. So remember, move with purpose, stay on course, keep control. It's time to test what you've learned. Choose the best answer. Question 1. Which component provides electrical energy to a robot? A. Sensor. B. Battery. C. Motor. D. Gear. Answer: B. Battery. Question 2. Which component acts as the brain of a robotic system? A. Controller. B. Wheel. C. Propeller. D. Battery. Answer: A. Controller. Question 3. Which component detects information from the environment? A. Motor. B. Gear. C. Sensor. D. Frame. Answer: C. Sensor. Question 4. What converts electrical energy into mechanical movement? A. Motor. B. Sensor. C. GPS. D. Communication module. Answer: A. Motor. Question 5. What produces thrust in a typical quadcopter? A. Battery. B. Propellers. C. Frame. D. GPS. Answer: B. Propellers. Question 6. What is the main function of a drone's flight controller? A. To store energy. B. To hold the drone. C. To process information and control flight. D. To produce electricity. Answer: C. To process information and control flight. Question 7. What type of drone movement involves rotating around its vertical axis? A. Hovering. B. Yaw. C. Forward motion. D. Landing. Answer: B. Yaw. Question 8. What does a drone do when it hovers? A. Moves rapidly forward. B. Rotates continuously. C. Remains approximately in the same position in the air. D. Turns off its motors. Dads, C. Remains approximately in the same position in the air. Question 9. Which sensor helps detect rotational movement? A. Gyroscope. B. Battery. C. Motor. D. Propeller. Answer: A. Gyroscope. Question 10. Why do robotic components need to work together? A. To make the robot heavier. B. To produce coordinated and controlled movement. C. To reduce the number of sensors. D. To prevent the robot from moving. Answer: A. Producing once sinner. Performance challenge. Now it's your turn to become a robotics designer. Imagine you are designing a simple delivery drone. Your challenge is to identify at least 5 components that your drone would need. Then explain the function of each component. After that, answer this question. How would these components work together to safely move the drone from one location to another? Think about the battery, the sensors, the flight controller, the motors, the propellers, the frame, and the communication system. How would they work together? Remember our key idea. Power plus sensors plus control plus actuation equals controlled robotic motion. And that's the end of our lesson on components of robotic motion and drone technology. Today, we discovered that movement isn't magic. It's engineering. It's coordination. It's teamwork between different components working toward one goal. So the next time you see a robot moving or a drone flying above you, don't just watch the movement. Ask yourself, what is sensing? What is thinking? What is producing the action? And what is controlling the movement? Because behind every successful robotic movement is a system working together. Sense, think, act, move. And remember our robotics hugot. Parang robot, hindi sapat ang gustong gumalaw. Kailangan mo rin ng power, direction, at control. Until our next robotics adventure, keep exploring, keep building, and keep making things move.
Thank you for learning with me today. Remember, biggest classroom. Don't forget to subscribe for more lessons. Keep finding the Hugot in every day. See you in the next lesson.